We are coming to you with a beautiful Christmas scene in the background that my sister put up recently and did an absolutely phenomenal job. My dad might have helped out a little bit. I can't take any credit. I did not. But regardless of that, it's Wellness Nerd Out time! How you guys doing today? Happy Wellness Nerd Out time. And a very, very happy birthday to my brother for life, John Souza Menu. Happy birthday, man. This one's for you. Forever Your Day in the Book of One Wellness. We'll talk about him more at the end. Happy birthday also to another brother, Patty Fonz. Love you too, man. This is your book, day in the book, as well. So what I wanted to talk about today, since we have some great people getting older, is a very fitting topic, and that is aging. So we would love to slow the process of aging to not age at all. Wouldn't that be absolutely fantastic? Unfortunately, our bodies aren't perfect. Biological mechanisms eventually fail, and we can't replicate our tissues quite as well as we may believe that we could. Again, biology, one of the most beautiful things about it is how imperfect it is. And eventually things seem to go wrong, but we can definitely mitigate our chances of having that occur, right? And so what is aging in itself? You know, many definitions, but one is a progressive loss of physiological integrity that's accompanied by impaired functioning and increased vulnerability to death. Well, what a fantastic thing. No, of course not, right? And most scientists would probably agree that if we live forever, the longer we live, pretty much all of us would get cancer. And we'll talk about exactly why in a second. But it should definitely be noted first and foremost that these wrinkles, this reduction in muscle mass, poor posture, all sorts of things, vision loss, all these things, they are macroscopic changes that are driven by changes at the cellular level, microscopic changes at the cellular level. And so if we can address these microscopic mechanisms, these cellular mechanisms, and we can do everything that we can to improve their functioning and sustain them properly, we are reducing our risk for developing disease and hence supporting anti-aging. Okay, so we said if we live for a long time, we would all probably get cancer. Well, that's a really dark thing, right? Well, here's the truth. When we look at something like genomic instability and senescence, now, genomics referring to genetics and the study of genetics and anything from the function or mapping of genes and all sorts of things of that nature, right? So genomic instability basically says that our cells are going to need to be replaced at some point. And so what we have to do to produce new cells is replicate the DNA. And if we replicate the DNA, this is something, by the way, that's happening really throughout our entire lives. Now, to replicate the DNA, we have to copy the DNA, and this is a daunting task. And to illustrate how very much so, take an average chromosome. It has anywhere from 50 million to 300 million nucleotides. Those are those bases that make up DNA strands, right? When we hear the A, G, C, and T, all that stuff, right? That you guys probably remember from way back when. So we have proteins, enzymes that are responsible for assisting this DNA replication process, and they are highly imperfect, right? So over our entire lifespan, and you look at all the chromosomes we have and all these nucleotides that are being replicated from cell to cell, day in and day out, there is actually a very high chance that something will eventually go wrong. And that's why we said that about the cancer, right? So this isn't just about cancer, it's not ominous. Depressing video. Now, what happens if the cell isn't replicated properly and if we have damaged DNA? Well, the body is very intelligent, and so it doesn't have to hold on to that cell. It can say, okay, let's kill this thing. Let's get rid of it. Just take it out. That's apoptosis, programmed cell death. And this occurs all the time throughout our lives. Now, another thing that it could do is it could go into senescence, can the cell. And senescence is when the cell just stops dividing over time. And if our body knows there's a high risk for mutation via imperfect DNA replication, it says, okay, it's not worth it. We're going to just tell this cell enough is enough, and it's going to stop. Okay? And so maybe you don't grow any more hair. Or maybe you don't do any, simple example, but maybe you don't grow any more new skin cells. It's this and that, whatever it is, right? And so when we have these senescent cells, they're just sitting around now, and the problem is they're releasing pro-inflammatory cytokines, and those are chemical immune messengers, right? And so that's not a good thing ever to increase inflammation in the human body, and we would obviously love to avoid it. So that's one of the biological mechanisms behind aging, is this process of genomic instability and senescence. Now, when we talk about the replication of cells in general, we have stem cells that can differentiate into new cells, more mature cells, and this happens pretty much throughout our lives, but eventually it stops. And an example is, you look at skeletal muscle. We have satellite cells that are produced after rigorous exercise, and also in the presence of a supplement like creatine, but exercise is a major driver. One of the mechanisms creatine promotes muscle growth is this right here. These satellite cells differentiate into immature muscle cells, or myoblasts. These myoblasts differentiate into myocytes, and they divide, and we produce more muscle tissue. Now, eventually, in part due to DNA damage, our cells don't quite do this as well, right? And so we have to remember also, if we're replicating these imperfect cells, that's where we got the whole cancer thing from, right? Which I should have said in the beginning. Right? Our body obviously would like to avoid that, but at some point it could be inevitable. But there are lifestyle modifications we can make to help prevent these things from happening. All right? If you guys don't feel like watching the rest of the video, long story short, it's exercising, improving mobility is a great thing for anti-aging. Getting more sleep, maintaining a healthy weight, having a healthy diet, and of course, stress, reducing stress would be a good thing. Albeit that wasn't one of the top things per exam, but the other four definitely were. So if nothing else, go exercise more, do more mobility stuff, sleep more, and have a healthy weight and a healthy diet. So when we look at the mitochondria are the energy powerhouses of our cells, and we go through both anaerobic respiration, where we don't use oxygen. We break down something like glucose and say in the cytosol outside the cell, and then when we get things transferred into the mitochondria, and we can break more things down, or if we're breaking fat down, it happens in there, and whatever it is, they all end up pretty much at the Krebs cycle, the citric acid cycle. It's an energy-producing pathway with intermediates such as citric acid and malic acid and alpha-ketoglutarate and fumarate, all that kind of stuff. You guys remember from biochem or whatever way back when. And it's an energy-producing pathway, so it's going to make a bunch of ATP. We're going to produce adenosine triphosphate. It's a major stored form of energy in the body. It's going to make a bunch of NADH2. It's going to make a bunch of FADH. And regardless of these silly names, it's not important you remember them, these byproducts of energy production then go into the intermembrane space of the mitochondria itself, so into the membrane now of the mitochondria. And they go through this process where our body uses more energy to create more energy. It uses these byproducts to make more ATP and to change electrochemical gradients, biochemical ion gradients, and it starts to produce more hydrogen ions, which are released at least out into the intermembrane space, into that acidic area. And the whole point is this electron transport chain, if you haven't heard of it, is something that will produce energy over time as a byproduct of what we've already made before that, right? And it's extremely important in maintaining energy production in our mitochondria. And over time, the mechanism here fails as well, or at least it becomes less perfect. And now the electron transport chain, these byproducts, we can start to produce not only less ATP, but to release reactive oxygen species, or ROS. And we know that oxidative stress is not a good thing. Reactive oxygen species aren't a good thing. That's why a lot of us take so many antioxidants, because we want to bind to those reactive oxygen species and negate the harmful effects that they have on other cells when they go out there hungry trying to bind other things and, pretty much make them not function properly or destroy them or whatnot. And so it's not a good thing, right? And actually, scientists for a long time thought that the release of ROS from the mitochondria was the primary driver of aging. Now, this is known to not be the only player nowadays, and ROS do play some positive roles in the body. We do need them for certain things, but for the most part, too much isn't a good thing, right? Interestingly, they've induced mitochondrial dysfunction in mice without producing more ROS, reactive oxygen species, from the mitochondria, and they still had the same aging effects. So that's one way that we know it's not just due to that, right? But the point is, this is something that increases inflammation, and this is something where now we have mitochondria that aren't functioning properly, and that's a huge problem, right? Well, normally it's not, because what our body can do, just like when our skin is fragmented, our DNA is fragmented from getting too much sunlight, we can repair it. We can repair or replace these mitochondria. But eventually, over time, our ability to gobble up the dysfunctional mitochondria and to replace them with new ones is diminished. And that's another way that we have these harmful effects of aging at the cellular level. Right? Now, proteostasis. Now, by the way, we're mentioning all this because we're going to talk about the supplements tomorrow that are the top supplements for anti-aging and why. And when we reference something like reducing the formation of ROS or DNA fragmentation or mitochondrial dysfunction, inducing mitochondrial repair, or eliminating the inflammation caused by senescent cells or senescent cells themselves, you guys will understand exactly why it makes sense, right? And that's really important, I think, if somebody's going to actually do something. You have to really know why it makes sense. Okay, so proteostasis is the last thing that we're going to talk about, and proteostasis basically is the process by which protein metabolism, or proteins themselves, are regulated in a cell, in the proteome, or the collection of proteins in a cell, how that is regulated, right? Now, and how they're replicated. And, we know that DNA is converted into RNA, that messenger RNA then, comes RNA, goes through the ribosome and converts it into protein. And so now we have these proteins that do all sorts of things in the human body, from serving to enzymes and getting involved in membranes and serving as signaling molecules and all sorts of things, right? Now, there are two really, really important things when it comes to a protein. It's the sequence of the amino acids that determines what type of protein this is, right? And so we have different sequences and all these different cells in our body, and they code for different things. And some sequences will code for skin cells or hair cells or whatever cells anywhere, right? Or things that just have functions to promote proper physiological functioning, things of that nature, right? So the sequence is really important, but also how these proteins fold is extremely important. And we want, when a protein folds properly, which is guided by what's called a chaperone protein, typically it chaperones it for protein folding, right? Easy to remember that one. The hydrophobic portions, or those that don't have as much of an affinity for water, are typically on the inside. They're buried deep, if this is our protein, in the middle. Well, that makes sense because we want the hydrophilic, the ones that have an affinity for water, on the outside, which are in contact with water. It's all over in the human body, right? And so they are more soluble when they have this type of folding pattern, where the hydrophilic portion is on the outside and the hydrophobic portion, is on the inside. And so solubility is an important thing. Now, what if they are misfolded? Now, when it becomes misfolded, the mechanism of protein folding begins to fail over time, and errors occur in translation, we could say. Right? Transcription's DNA to RNA, translation's RNA to protein. Essential dogma of biology. When errors occur, it's not only pro-inflammatory, but also becomes stickier. So now it becomes stickier. And these sticky proteins are evident in many neurodegenerative diseases. A classic example would be what? Alzheimer's disease, right? Beta amyloid plaques, of course. And we can't forget about things like Huntington's disease or Parkinson's, where we have the accumulation of aberrant proteins as well, right? And so that's another mechanism that we would like to put a halt to, or at least improve as much as we can. Now, when we exercise and we go through forms of healthy stress, it supports the formation of more of these chaperone proteins, or improves their functioning. And so they assist in protein folding to a greater degree. So exercise can help to ensure directly that your proteins are folding properly. If your proteins are folding by assisting chaperone protein production, right, and action. And so if they're folding properly, they're less sticky. And if they're less sticky, that means they're not going to stick to your brain and cause dysfunction. Your body naturally will be able to degrade them with something like autophagy as well, which alternate day fasting in mice has shown to occur, right? Has supported, we should say perpetuated. And so it has been replicated in humans as well, has that mechanism. So something like exercise, something like fasting, they help you in so many more ways than you know. It's not just about building muscle, it's not just about burning fat, not just about having good skin, breaking a sweat, and heart health. It's about the health of your entire body, of your brain, of how your proteins are folding, how your mitochondria are being replaced, how your DNA is being replicated. All these sorts of things, we can do our best to ensure that they occur in the best possible way that they could throughout the duration of our lives. And having a healthy diet, eating naturally, not having any toxins and chemicals, well, that's such a huge thing, right? And you'll notice that a lot of these cause what? Having these abnormal proteins causes inflammation, right? This mitochondrial dysfunction causes inflammation. These abnormal cells, the DNA isn't replicated properly, these senescent cells that have been shut down pretty much, they release inflammatory signals. So we would love to reduce inflammation. And it's interesting that both of the things aforementioned, the exercise and the fasting, for example, there are many other things that are good for you, but these are just two hallmark examples that are well proven in science for these benefits, right? These are things that also reduce inflammation. So, very, very interesting. You can take all the anti-inflammatories you want, but if you just target inflammation, a lot of that is the byproduct of things that have already gone wrong, right? So we would like to correct be prophylactic and do things in the preventative sense to ever prevent this from happening. So there's another reason to maybe exercise, get some more sleep, to do some mobility exercises, keep yourself nice and limber so you can move properly. Make sure you're eating all things from nature, right? And maintain a healthy weight and be, as little stressed as possible. Just be happy and enjoy your life. So that's what we got for you guys today. I know that was a lot, but I wanted to dive into the mechanisms. So tomorrow we're getting into supplementation for anti-aging. And there's some supplements that are good for a lot of other things as well. And we will tell you just why. Happy birthday, John Souza Menu. Happy birthday, man. You're absolutely just one of the greatest people I know. I really mean that from the bottom of my heart. It's so funny because when we first met, I always tell this story to people, how you slept over and we had the rugby game. I think it was at Malloy the next day, right, or something like that. Or maybe it was the other game that we went and we had the black coffee before. Me and John, the other Bash bro, the Bash brothers, man. And, you told me that day after you went to bed off of some nice lasagna that we got, and by nice I mean Stouffer's, you were woken up by a vacuum this close to your face. And my mom is extremely routine. So, I'm sorry about that, but you still played pretty well, man, so it didn't seem to matter. You got to try this, by the way. This is ginger, frozen blueberries. It's the Oikos yogurt. I know you would like this because you like the other one. It was collard greens, actually, I put in this. Frozen collard greens. I blended up, and some kefir. That was the other thing. And water. But it's good. Try it. But I think of that, right? I think of that, and I think of, I think of those first games is one of the things that just comes right into my head. And obviously us commentating on the B-side games when we would film them. You got that right, Joe. You true that, Jim, His hair's looking great out there today, Joe. He must have really done his due diligence this week and got a fine haircut from a fine barber. Saying stuff like that to a rugby game, So we're watching the film, and you could hear the sound. We didn't know it was going to be like that, so we just started playing, and we were screwing around the whole time. And my coach, I don't think he found it that funny. He found it rather distracting. But I think everybody else thought it was pretty funny. So, shit, that was a great time. I think of that. And, what I love so much is, we had all these good times at Stony Brook. We had all this fun, shared all this love and experience. And now we're reunited. I hadn't seen you in, what was it? It was like 8 years or 9. It was a long time we said, right? It was a long time. And, we picked up right where we left off. Some people you talk to, and I've told you most of this, because we talk. You're the only person that comes over. If you come over for an adjustment and then we hang out for like 3 hours, It's just, every appointment's not a 3-hour appointment, guys, I promise. But we had a really good time. We just clicked, man. We're just like souls. We're like dudes. And, I'm so glad again that we're hanging out again. It's my absolute pleasure to see you whenever I can. And you just have a great heart. You have a great spirit about you. You have a great mentality about life. And, I feed off that. You feed off whatever I'm putting out there, and I hope it's something that's good, for both of our sake. And, this is absolutely a pleasure to wish you a happy birthday today and to say that it's your day in the book of Wen Wellness. So I hope you have a fantastic night tonight. If you need an adjustment, call me. I'll be around. Love you, brother. Happy birthday, Patty Fonz. Happy birthday, man. Patty, shit. You know what I think of? You're going to laugh. I think every year I talk about us shooting fireworks out of the Uber. They had Roman candles, which was freaking nuts. I talk about that. But I think of you being a scrappy bastard in rugby, definitely. Rather ephemeral period we were able to play together. But it was a good one. And I think about, I got a man of the match ball, and I remember I gave it to you because I thought you were retiring. This just came into my head. You were retiring, right? So you Brett Favre'd it, and you came back, and every week you were retiring, and you just kept playing. I think you still have that ball, so enjoy that. Consider that your birthday gift today. Nah, man, it's just that's funny. I love you, man. You're a great dude, and you're a family man now, so. Congrats on that. Do great things for yourself this year, great things for them. You deserve that. Great Cairo, great guy, great rugger, and you'll always be a great friend and a brother. So this one absolutely is for you as well. I love you, man. Happy birthday. Your day in the book of Wen Wellness. I'll see you soon. Say what's up to Dap. How you doing, girl? You watching right now? That's a 5 for you. Jerry Butler. How are you, my friend? What's up, Ma? Hey. Not by coincidence, Midnight Girl, Mano Salva. Sean Keith, Hardy. How you guys doing? Jesus Garcia, Bartow, M. Ray. Mega B Pablo, DOS 4371. Bull City King, Randy Stanley. Some of the ingredients, by the way, help reduce the harmful effects of aging. So, check out Super You. If you want a sample, you give me a shout. I'll send you some. How about that? And do a video on that. This village, man. He's killing it out here. What's up, Baker? Ivan, what's up, man? Thank you, brother. I appreciate that. Edwin Eddie Rodriguez, Meg. Say, what's up, Meg? How you doing? I just got a big bite of ginger. Say goodnight, Choke. And Liebe Kiever 9, first one on. Appreciate you. I hope you have a fantastic day today as well. You're getting a shout out today too, of course. So thanks for supporting Wen Wellness. Thank you all so much. You have a fantastic rest of your night. That's all we got for you, folks. We'll see you tomorrow, baby. Not sure where, not sure when, but we'll see you then. Have a great night. Thank you. Happy Wen Wellness. We'll see you guys tomorrow to talk about some supplements that support anti-aging, reduce the harmful effects of aging. See ya.